Hey everyone, welcome back to the RBT Security YouTube channel. In today's video, we'll explore port forwarding to access services during a penetration testing scenario. This technique is beneficial for accessing restricted services running on client systems or even services hosted on our pentest appliances. We'll walk through a scenario involving local and dynamic port forwarding to access tools like Nessus and file sharing services while keeping the setup secure and efficient. Let's break it down step by step. We'll begin by forwarding port 99992 from our pentester machine to our Kali instance, which acts as a SOX proxy in our machine. From the Kali instance, we use dynamic port forwarding to set up a SOX proxy on port 9992. This proxy will allow us to route traffic dynamically to another machine, Falcon. Finally, on Falcon, we'll again use local port forwarding to forward ports 8834 for Nessus and 5550 for Updog back to our pentester machine. This will allow us to interact with these services locally. The final destination is a GCP appliance hosting these services, and our SSH tunnels will allow us to interact with them as if they were running on our machine. Let's get started. First, we'll forward port 9992 from our pentester machine to the Kali instance. This allows us to send traffic securely to the first machine in the chain. This command creates a tunnel through which traffic sent to port 9992 on your machine will be forwarded to the Kali instance. Once on the Kali instance, we'll set up dynamic port forwarding. This creates a SOX proxy on port 9992, which can dynamically handle traffic to multiple destinations. This proxy is like a middleman that routes our traffic to other machines in the network, in this case, the Falcon machine. Next, we'll create additional port forwards from Falcon to access any services, but in our case, it's Nessus and Updog, which are running on a GCP appliance back to our pentester machine. Port 8834 will forward traffic to the Nessus service. Port 5550 will forward traffic to the Updog instance used for uploading and downloading files. Before accessing Nessus, we must confirm it's running on the GCP appliance. Let's SSH into the GCP appliance and check the status of the Nessus service. If Nessus is active and running, we're ready to proceed. To access the forwarded services, we'll set up FoxyProxy in our browser. FoxyProxy allows us to use SOX proxies or forward-specific traffic through different configurations. We have two SOX proxy options available, port 9991 from a previous configuration, port 9992 for the current setup. We'll use port 9992 for this video to route traffic through our SOX proxy. Open Firefox and try accessing the Nessus service without enabling the proxy. You'll notice it isn't accessible because the service isn't exposed directly to your network. Next, enable FoxyProxy with the SOX proxy configuration for port 992. Refresh the browser and you'll see that Nessus is now accessible through the tunnel. We can verify the Updog server and confirm that we've successfully forwarded both services to our local machine. In this video, we demonstrate how to securely use SSH Port Forwarding to access restricted services during a penetration test. We combined local and dynamic port forwarding to create a secure path to services like Nessus and Updog running on a remote network. This method is especially useful in complex network environments where direct access isn't possible. This technique is invaluable for red teamers and penetration testers working in complex network environments. I hope you found this walkthrough informative and helpful. If you have any questions or need further clarification, feel free to leave a comment below. For more information, visit our blog at rbtsec.com/blog. Don't forget to like, share, and subscribe to our channel for more cybersecurity tutorials and walkthroughs. Thanks for watching, and until next time, stay safe and keep learning. RBT Security. Thinking like hackers to protect as experts.